So let's take a look at how we can use this and why it would be beneficial to us. Alright, so for our supersonic flow analysis, I've got a 155 millimeter projectile. This is often or very similar to what's shot out of a howitzer. And so I thought I would show you guys just how easy it is to set up a supersonic flow analysis and see what the airflow looks like around this projectile. It's just a little bit different analysis, but this would translate also onto like wingtips of a plane. You could see if you're getting supersonic flow or maybe vortices around wingtips. You can talk about like efficiency of those edges, and so here we're going to just see how kind of efficient this this projectile is going through the air. So first thing I'm going to do is turn on my flow simulation, add in. Once I get this turned on, we're actually just going to walk through the setup process for this, and honestly that's relatively straightforward. So we'll go to our flow sim tab, we'll go to our wizard tool, and this is going to allow us to create a project, and it's kind of going to walk us through all the steps needed. So the first thing we're going to do is define the units. We're going to leave this in SI units. All we're going to be interested in here is fluid flow, and we're going to run it as an external analysis. Only gas we're going to be running today is air, right? So this is our main fluid. And we're going to turn on this high Mach number flow variable since we're doing a supersonic analysis. We'll leave our default settings for adiabatic walls. And I'm going to go in here and just verify that all of this looks correct. So temperature, let's jack this up since it's going to be flying pretty fast. And we're going to have this going at 1.7. Now I actually need to change my velocity to a Mach number. And now we've got a negative 1.7 Mach for our airflow around this. And it's going to be traveling in the negative Y direction. At this point we can hit finish, and what's interesting is our computational domain has been modified. Maybe I'll change this to be like 1 meter in each direction. I think 1 meter is probably enough for us to see the airflow. So now we've got our kind of cube. Maybe I need to lengthen that just a little bit upwards. So let's go in the Y direction. Maybe just make that 2. Cool. So now I've got our computational domain, and there's not really a whole lot left to set up for this. We're just going to come up here and we're going to select run. This is going to take a minute, and so we'll let this run. Okay, now that that's done solving, let's take a look at the results. We can throw in some cut plots. Maybe we want to see the pressure or the Mach number on the front plane section. We zoom in here, we can actually see the Mach number of the airflow. Pretty interesting, right? So 1.7 is our average airflow, so anything greater than that is going to be, anything greater or less than that is going to be due to the projectile, right? So anything that's not orange. We could also throw in, maybe a pressure gradient. We can see what our pressure looks like here. Looks looks very similar to the Mach as far as the pattern and the airflow. So just wanted to show you guys, maybe another useful tool if you already have SOLIDWORKS Flow, or a tool that you may not know was possible as far as running Supersonic Flow on these in FlowSim, right?